Hello everyone, this is Dilip. In the last video, we have spoken at length about overfitting and how regularization helps in solving it. We have also seen how regularization works in linear regression. In today's video, let's talk about regularization in terms of logistic regression. I will leave the link for last video in the description. So, what is overfitting in classification problems? So if you see, this is a picture showing apples and bananas. And if you fit a decision boundary and picking up linear hypothesis, the decision boundary looks like this. So all the input data, if it results in the hypothesis having a point over here, then it is a banana. If it results in the hypothesis having a point over here, it's an apple. Now, taking the quadratic equation, we'll get a curve like this for decision boundary. So all the points to the right of this curve, those are apples, and left are bananas. And if you take a much higher order polynomial, that will help us in fitting all our data perfectly well. What we get is a curve that looks like this. So as you can see, this curve tries to fit the test data as much as possible. And if we input other data which is not in the test data, we get the wrong result. So this is overfitting in classification problem. So we need to change this equation to a similar to a quadratic equation or a lesser order polynomial equation so that we get curves like this and we doesn't go for overfitting. So similar to what we have seen in the linear regression. So here also we need to penalize the cost function using the regularization parameter lambda. So here the cost function is this for classification problem for logistic regression. And we add the regularization parameter lambda times all the parameters are squared. So this will help us prevent overfitting. Now, if we take the derivative and write the gradient descent equation in the pseudocode format, it will come like this. So as you can see, this looks same as the linear regression gradient descent. The difference being the hypothesis H. Here it indicates 1 by 1 plus e to the power of theta transpose x minus theta transpose x. So here the hypothesis indicates a sigmoid of the linear regression type hypothesis. That's why we get a hypothesis that is between 0 and 1. And if you want more information on the logistic regression, that link also I'll give in the description. So ultimately, we get the gradient descent equation like this. And if you are using advanced optimization techniques also for regularization, you're calculating the cost function and calculating the derivative of it. So here the derivative term is this and this term. So these you need to pass into the calculation of this, you need to pass into the advanced optimization techniques. So this is how we solve the logistic regression problem with regularization. Thanks everyone for watching the video. Bye.